Hi everyone, I hope you're okay, and I hope that guys the videos will keep uploading and helping you out. This is the 6th video guys from the 12 promised videos of me answering the past exam question papers with regards to vertical projectile motion. Please note that guys other videos are already being uploaded, and obviously you'll find them if you click the link on the description below. There's a playlist there. You can play them from video number 1 until the last video. And the second playlist, that's where I teach vertical projectile motion from scratch. Please guys do note that your engagement is highly appreciated. Don't forget to like, share to your peers guys. A thing or two that I mention here might help them, and most importantly, don't forget to subscribe. Okay, we are told that a ball is thrown vertically downwards from the top of a building, and it bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it is thrown up to a certain time t. Okay, take downwards as positive and the ground as 0 reference. The graph is not drawn to scale. The effects of air friction are ignored. Okay, if you can check here guys, by just analyzing this graph, this is the point of projection, whereby the ball is still at the top of the building, and then this is point B when the ball reaches the ground, and then point C when the ball leaves the ground after the first bounce. Are you together? Whenever your graph intersects the x-axis, please note that that's when your graph reaches a maximum height. Are you together? So this will be point D, my maximum height. Point E, when the ball returns to the ground, and then point F, when the ball leaves the ground, and then it goes to maximum height at point T. So if you would illustrate the motion of the ball, it will be here from the top of a building. It will go down, reach the ground, stay a little bit, go up to maximum height, come back, stay a little bit, and then go to a second maximum height, U. That's maximum height, coming back, and then it reaches the second maximum height. So this will be the motion of the ball now. And whenever you label, this will be position A, B, C, D, E, F, and position T. Are you together? So this will be the motion of the ball from the top of the building to the ground, and then it stays a little bit for 0.2 seconds. Then after 0.2 seconds, it bounces to maximum height, returns to the ground at position E. It stays a little bit for 0.29 seconds, and then it goes to maximum height at point T. This is the illustration of the movement of the ball. Now let's start to answer the questions. Should I erase this? Okay, let me leave it. Write down the speed with which the ball is thrown downwards. Okay, here the y-intercept will represent the initial velocity of the ball. So the speed here they're referring to, that's 10 meters per second. Okay, and then you're told that all parts of the graph have the same gradient. Give a reason. Remember that guys, the gradient under the velocity time graph represents acceleration. Since the ball is under free fall, the only acceleration it will have is gravitational acceleration. And the universal gravitational acceleration is a constant. It doesn't change. So that's why the thing, that's why we have straight line graphs which are parallel. Are you together? Just to show that they have the same gradient. Are you together? If you can calculate the gradient, taking any 2 points, maybe point A and point B, you'll simply find out that the answer will be 9.8. Just to show that the gradient represents the gravitational acceleration. Okay, calculate the height from which the ball was thrown. I'm going to answer this question in two ways. Firstly, by just using equations of motion, and then secondly by using the graph. Because sometimes they can say to you, use the graph to calculate the height of the building. Are you together? So whenever you use your equations of motion, you are focusing on path A, B. The initial velocity, that's 10 meters per second. Remember that we were told to take downwards as positive, so that's positive 10 meters per second. The final velocity, the velocity of the ball at B, that's positive 29.6 meters per second. Gravity, since you are taking downwards as positive, let me highlight this, take downwards as positive. Since you are taking downwards as positive, my 9.8 will be positive as well, meters per second squared. I want to find out delta y. I don't know the time. So for me to find the height of the building, rather, I must simply refrain from using any equation that has time. The only equation that does not have time is the second equation. Are you together? I'll simply say Vf squared is equal to Vi squared plus 2g delta y. The final velocity, that's 29.6 squared, and this will be positive 10 squared plus 2 times 9.8 multiplied by delta y. You'll obviously use your mathematical gymnastics and find your delta y to be, let me punch my calculator, 29.6 squared minus 10 squared all over 2 times 9.8. You'll simply get 39.6 meters. Are you together? Another way, guys, you can find the area underneath the graph. Area underneath the velocity time graph will always tell you about your displacement. Are you together? So we'll obviously focus on this shape over here. If you can check here, this is a trapezium. Are you together? And area of a trapezium, is always half the sum of the two parallel sides. Let's call this side x and side y. X plus y multiplied by the perpendicular height. Are you together? These two are vertical lines. Both of them are parallel, and then the side which is perpendicular to side xy is this one. Are you together? So you just need to substitute over here. The aim is not to sweat, ne? I'm kidding. The distance x, that's 10 units, and this one, that's 29.6 multiplied by the height, that's 2 seconds. Oh, I actually have the time it takes for the ball to reach the ground. Excuse me about that, guys, ne? That's 2 seconds. So here I could have used any equation to find out delta y. Any equation besides the first one. What do I get? Let me check. 1 over 2 multiplied by 10 plus 29.6 multiplied by 2. We still get 39.6 meters. Are you together? Always the time, guys, to find displacement, just find the area underneath the graph. Are we together? And the area underneath the graph, you are simply going to take the space between the right hand side of your graph and obviously your positive axis, and then you'll connect the ends. So we just wanted to find this area over here. If you didn't know how to find the area of a trapezium, you could have done this, divided this shape into two, né? Find area of the triangle and then add it to the area of this rectangle. All together, the dimensions would be 2. You'll have 10 here, and obviously it will be 19.6. That's 2 as well. Yeah, well, you can simply find your areas and work out. But luckily in this question, we were not forced to use the graph, né? Yeah, I could have used the equations of motion as we did there, or just use the graph. There's nothing wrong. Okay, now they want us to calculate time t. They want us to find out the time it took the ball to reach maximum height, né? Where should I write? Space, la. Okay. Let's focus on path ft. Path ft. The initial velocity that has to be given, that's negative 25. Why is it negative? Remember that, guys. At point F, the ball is leaving the ground and it goes upwards to reach maximum height. And we were told that downwards is positive. That means upwards movement has to be negative, né? So the initial velocity is negative 25. Okay, negative 25 meters per second. Final velocity, the velocity of the ball at position T, that's maximum height. The final velocity, that's 0 meters per second. Gravitational acceleration, I don't care about the motion of the ball. Since I've chosen down to be positive, my acceleration will be positive as well. Delta y, I don't know that. I just want to find out the time it took for the ball to reach maximum height. How can I do that? I can simply use the first equation. I know that I'll say Vf Vi plus G delta T. The final velocity is 0. The velocity of the ball at maximum height is 0. The ball bounced upwards at the velocity of negative 25 meters per second, multiplied by 9.8 times with delta T. Take the 25 to the other side, it will be positive 9.8 times delta T. Divide both sides by 9.8. 25 divided by 9.8. You'll simply get 2.55 seconds. So now check, guys, the distance from here to there, that's 2.55 seconds. Are you together? They want us to find the value of t. So t basically will be equals to 8 plus 2.55 seconds. That's 10.55. So t will be just equals to 10.55 seconds. Are you together? Remember that, guys, the 2.55 is just the time it took for the ball to move from the ground to maximum height. Are you together? But we must obviously add the 2.55 from the 8 to find the actual value of t. Okay, the height, what did we get for the height? Height is 39.6, and then t is 10.55 seconds. Okay, then I must write down the time write down the time the ball is in contact with the ground at the first bounce. They want us to find the difference between these two given times. So the ball will be in contact with the ground for 2.2 minus 2. That's actually 0.2 seconds. So that's 0.2 seconds. Write down the time at which the ball reaches a maximum height after the first bounce. After the first bounce, okay. We must find the remember that, guys, D is the first maximum height, T is the second maximum height, right? They want the time for the ball, the time that it took the ball to reach a maximum height after the first bounce. The time, what's in it? Okay, I must just say 4.99 minus 2.2. 4.955 minus 2.2. So after the first bounce, it only took the ball to reach maximum height. How many seconds? 2.755 seconds. Okay, then now I must calculate the value of x. Okay, the value of x, guys, please remember that now let's go to a symmetry in projectile motion. The velocity of the ball at C will be equal to the velocity of the ball at E. The velocity the ball will leave the ground at will be the same velocity the ball will return to the ground at. Are you together? The only difference will be just the direction. So the value of C and E has to be the same. The only difference should be signs. Are you together? So the value of x is just negative 27 meters per second. Are we together? And then is the collision of the ball with the ground elastic or inelastic? Give a reason for the answer using the information of the information in the graph, rather. Remember that, guys, collisions are elastic if and only if kinetic energy is conserved. Are you together? And for kinetic energy to be conserved, the velocity must not change. If the velocity changes, that means kinetic energy is not conserved, and hence the collision has to be inelastic. So here we can see that, guys, okay, for the first bounce, the ball reached the ground at the velocity of 29.6 meters per second. Are you together? However, it left the ground at a speed of 27 meters per second. It simply means that when the ball bounces, the kinetic energy was converted to other forms of energy. Are you together? Probably sound energy and heat energy. Are you together? So in this case, guys, kinetic energy is not conserved. Why? Because the velocity is not conserved. You cannot conserve kinetic energy without conserving the velocity. Are you together? So by just looking at the graph, you can see that the collision is inelastic. Why? Because kinetic energy is not kept constant. Simple as that. Yeah, that's how, guys, we're supposed to answer this question. I believe it was a little bit interesting. Just stay tuned, guys. Wait for more videos. Share, guys, to your friends. A thing or two that is mentioned here might help them. Comment, do ask questions, don't be afraid, and most importantly, guys, help us grow the channel. Subscribe. Thank you very much.